Hi friends, good morning. So today we're going to discuss about compiler design subject. So before going to our actual subject or actual concept, first we should know what a compiler is. What does a compiler do? What are the basic functionalities of a compiler? What is a compiler and what is an interpreter? What is the exact difference between those two? So later on we can discuss about the phases of a compiler, right? So first, what is a compiler? A compiler is also called as a translator. So basically we know what a translator is, what's the use of a translator, right? So in general sense, for example, if a person knows only Hindi and if he wants to speak in Telugu, he doesn't know Telugu, what does he do? He will hire a translator. Whatever he talks, he will translate that into Telugu. If he talks in Hindi, the person talks in Telugu. So here a compiler acts as a translator, which means that your input will be in one form and after converting the output will be in another form. Okay, so a compiler is also called as a compiler is also called as a translator. Will give input as a source input and this translator converts that to target output, which is exactly different with source input. Okay, so a compiler scans each and every statement from left to right. Okay, so I hope you understood what a compiler is. Here the source language can be C, C++, like that. See what are we saying here? Compile is a translator which converts the source language into target language. We call the target language also as a machine language. It's a machine understandable format. So your target language can be machine language. I hope you understood the difference between a compiler. A compiler is a translator which takes input in one form and converts that to a machine level, a machine understandable format, which is also called as a target language, which is in another form. So that is the basic functionality of a translator. Now, see here, compiler which takes source input and converts that to target output in another language. So source language or source input is converted to target output, which is also called as machine output, which is a machine understandable format. Now, what exactly is a compiler? So compiler is analysis synthesis model. So what is a compiler here? Compiler is analysis synthesis model. So compiler is divided into two, front end of a compiler and back end of a compiler. So that's the reason I'm dividing compiler into analysis and synthesis part. So what does analysis part contains? What does synthesis part contains? So now we'll see. So if you see here, as I said, compiler we have two phases. One is analysis and synthesis. If you see, I have a source program and I need to generate a target output or a target program. So in between I have a compiler. Compiler does that job. So compiler is divided into two phases. One is analysis and synthesis phase, right? So what is analysis phase here? Analysis phase takes a source program and breaks down that into consecutive pieces. For example, if I take any input, that input is divided into consequent pieces which we call as tokens. So analysis part covers three phases: lexical analysis, syntax analysis, semantic analysis. Whereas once your source program is divided into consecutive pieces, then we have an intermediate code, right? So that intermediate code is generated as a target program during synthesis phase. So in synthesis phase, we have code optimization, intermediate code generation, code optimization, and code generation. Okay, so total we have 6 phases here: syntax analysis, semantics, lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, code generation. So that's the reason it is divided into 2 phases here: analysis part and synthesis part. Now we'll see analysis part. So in analysis part is divided into 3: lexical analysis, syntax analysis, semantic analysis. So what exactly I said for analysis part, your source program is divided into consequent pieces, right? So gathering all those parts, which is intermediate code is generated. From that we convert that to target output code, right? So this analysis part contains lexical analysis. Now we'll see what is lexical analysis, syntax analysis, semantic analysis. So just now I said we have front end of a compiler and back end of a compiler. So what exactly is this? Front end of a compiler contains 3 phases: lexical, syntax, semantic analysis, and back end of a compiler contains 2 phases: code optimization and code generation. So in between front end and back end, I have intermediate code generation. So intermediate code generation acts as an intermediary between front end of a compiler and a back end of a compiler. I hope you understood. So if you see front end and back end of a compiler, just now I said, we'll start with the source program, and in front end of a compiler, we have 3 phases which we call it as analysis phase basically. So as you know, compile is divided into analysis phase and synthesis phase, right? So analysis phase contains lexical analysis, syntax analysis, semantic analysis, whereas synthesis phase contains intermediate code generation, code optimization, and code generation. So coming to front end of a compiler, we have a lexical analysis, syntax analysis, semantic analysis. So coming to back end of a compiler, back end contains only 2 phases: code optimization and code generation. So in between a front end of a compiler and a back end of a compiler, I have an intermediate code generation, and finally the target output is generated. So this is what exactly happening in front end and back end of a compiler. Now we'll see properties of a compiler. So now we'll see properties of a compiler. So the first and foremost property for a compiler is compiler itself must be bug free. So what does a compiler do? Compiler will scan each and every statement. If at all any error messages occur, it throws an error message, and finally those error messages should be solved. Now if compiler contains bugs, then there is no use of using that compiler, isn't it? So compiler must be bug free first of all. Second, must generate correct machine code. So compiler must generate correct machine code. Why? Because first we give a source program and the target machine code will be generated, isn't it? So the target machine code which is generated should be correct, and the generated machine code should run faster. Okay. So if the machine code which is generated, if is running slowly, then there is no use of a compiler. And the most important one is the compiler must be portable. And the last one, the compiler must have consistent optimization. So we're not fixed to 5 properties of compiler. Here I am discussing only the most important properties of compiler. So with this we learned what are the basics of compiler, what is the front end of a compiler and back end of a compiler, how compiler is divided into different phases like analysis and synthesis phase, and what are the properties of compiler. And in my next class we'll discuss about the phases of compiler, which is most important. So it is divided into 6 phases, including with symbol table management and error handler. How your source program is processed and how you get your target output code is our concept. So I hope you understood the basics of a compiler. So if you like my videos, please share my videos to your friends and please subscribe to our CSC Pedia channel. I'm very thankful. Have a good day.